Hello, I am so excited to join you in this episode where we are going to look at different flavors of questions involving alpha and beta, which are roots of a quadratic equation. We want to express these terms in terms of A, B, and C. So first of all, remember that alpha plus beta is given by negative B over A, and alpha multiplied by beta is given by C over A. Now, the first important expression that we are going to need is alpha plus beta squared, which is equal to, so expanding this gives alpha squared plus 2 alpha beta plus beta squared. So this implies that, so we are going to make alpha squared plus beta subject to the formula. So this is alpha squared plus beta squared is equal to, on the left side we have alpha plus beta squared, then minus twice alpha beta. So let us underscore this. Will be very useful in everything we are going to do. So number one, we have, right away I'm going to expand this, which gives us alpha squared minus twice alpha beta plus beta squared. Okay, so we can write this as alpha squared plus beta squared minus twice alpha beta. Okay, now we know what alpha squared plus beta squared is here, which is just alpha plus beta squared minus twice alpha beta, and then there is also minus here twice alpha beta. So this gives us, this is alpha plus beta squared minus 4 alpha beta. Remember, in every expression we are looking for alpha plus beta and alpha beta. So that was number one. Number two is alpha minus beta. Okay, so we already know what alpha minus beta squared is, which is alpha plus beta squared minus 4 alpha beta. So we're just going to take the square root of our previous expression. So remember, alpha plus beta is negative b over a, and alpha beta is c over a. All right. Our next expression, number three. So you can see that if you look at alpha squared minus beta squared, there is no expression necessarily that you can expand to give you something related to this. However, we are going to use the difference of two squares. So this is just alpha minus beta and alpha plus beta. All right. So in number two, we know what alpha minus beta is. We know that alpha plus beta has a known value, and alpha minus beta is this square root. So we take the square root of alpha plus beta squared minus 4 alpha beta. So you can see that everything is depending on where we are coming from. All right. Number four is an exciting flavor. This is alpha over beta plus beta over alpha. Let us try to express this as a single fraction. Common denominator is alpha beta. So this is alpha squared plus alpha into alpha. Beta is beta. Beta multiplied by beta is beta squared. Okay. Next, we have alpha squared plus beta squared, which we already know. Remember, this is what we circled here. So right away, I will substitute. I will write over alpha beta. And we are done. Our next expression is alpha power 3 plus beta power 3. So you can see that this is something that is coming from some alpha plus beta cubed, right? So let us try to expand alpha plus beta cubed. Okay, so this expands to. So if you don't know how to expand this, first you can use the binomial theorem or Pascal's triangle to expand this. If you have not done binomial or Pascal's triangle, you can just expand alpha plus beta, alpha plus beta. You know this, and then the answer multiplied by alpha plus beta. This should simplify to that. Now we are looking for alpha cubed plus beta cubed. All right, so we are going to take everything, we are going to take all these terms here to the left side of the equation. So on the right, we remain with alpha cubed plus beta cubed is equal to, on the left, we have alpha plus beta cubed minus, so everything here, I'll just write alpha 3 alpha squared beta plus 3 alpha beta squared. Now we want alpha beta and alpha plus beta. So this is equal to alpha plus beta squared. This is squared minus. So you can see that alpha beta is common in here and 3. So I factor out 3 alpha beta. What do I remain with here? I remain with alpha plus. Here I remain with beta. So therefore, alpha cubed plus beta cubed is equal to that. So you can see that the expression only contains alpha plus beta and alpha beta. So this is done. The next flavor is 1 over alpha squared minus 1 over beta squared. So straight away, we are going to express this as a single fraction. In the numerator, we're going to have beta squared minus alpha squared, then over alpha squared, beta squared. In the numerator, we can apply the difference of two squares. This is beta minus alpha, beta plus alpha. Everything, so this is just the same as alpha beta squared. That is alpha squared beta squared is just the same as alpha beta squared. Okay. Now, here we have beta minus alpha. Remember, number 3, we found the expression for alpha minus beta, which is alpha plus beta squared minus 4 alpha beta, then everything under the square root. So we're going to mimic that and rewrite this in terms of alpha minus beta. So this is minus, we are going to factor out the negative here. So this is minus, this is alpha minus beta. So we just factored out a negative in the first term. So we have minus alpha minus beta. Then this is alpha plus beta over alpha beta squared. Okay? Now, what is alpha beta? So we have minus alpha beta in number two. We had this was alpha plus beta squared minus 4 alpha beta. Okay, so this is everything multiplied by alpha plus beta, then everything over alpha beta squared. So that is the expression. The only remaining is substitute what your alpha plus beta is, that is your negative b over a, and the alpha beta, which is the c over a. The last flavor in this series is 1 over alpha squared minus 1 plus 1 over beta squared minus 1. So in this case, again, we're going to express as a single fraction. In the denominator, we have alpha squared minus 1, beta squared minus 1. All right, so if we take the division, we have beta squared minus 1 plus alpha squared minus 1. Okay, now this is alpha squared plus beta squared minus 2 everything over. So now in the denominator, if you want, you could apply the difference of two squares, which would not work because you have alpha minus 1 and alpha plus 1. Instead, we are going to expand. So expanding this gives us, okay, we know what alpha squared plus beta is, which is alpha plus beta squared minus 2 alpha beta, but we have minus 2 again. Okay. Now, in the denominator, alpha squared beta squared is just the same as alpha beta squared. Now, in the denominator, alpha squared beta squared is just the same as alpha beta squared. Now, here we have minus alpha squared minus beta squared. I will factor out negative 1. So this is negative, and inside I will remain with alpha squared plus beta squared plus 1. Okay, so I write again alpha plus beta, that is the numerator, minus 2 alpha beta minus 2. Okay, in the denominator, alpha beta is already simplified minus. Now, what is alpha squared plus beta squared? We are just from substituting. This is alpha plus beta squared minus twice alpha beta. Okay, then plus 1. So you can see that in our expression, we only have alpha plus beta and alpha beta. So you can go ahead and substitute what these values are, the alpha, beta, and solve your problems. So for now, we end here. Don't forget to share, like, and send us your comment where you're watching us from. Thank you.